So in Chapter 9, we are going to talk about sequences. In class, we will go through the answers to all these sequences as far as the next 3 terms in each one, so work on those on your own. And now we'll go straight to some vocab. A sequence is an ordered list of numbers. So it could be something like 2, 4, 6, 8, some kind of list of numbers that has a first term, a second term, a third term, a fourth term, etc. A series is the sum of a sequence. So you might add up the first 5 terms of this sequence: 2 plus 4 plus 6 plus 8 plus 10. And whatever that sum is, that would be the series. When we look at different sequences and series and things like that, often we will come across something called a factorial. And a factorial, it looks like an exclamation point. I'll just use an N to start with. And what that means is you take, I'll do the example first. You take, if it's 4 factorial, you take the number and multiply it by every number less than that until you get to 1. So 4 factorial would be 4 times 3 times 2 times 1. So it'd be 24. N factorial would be n times n minus 1 times n minus 2, all the way until you get to 1. So you start with that number, 1 less, until you get to 1. Here is an example of a formula to create a sequence. It just has n's in it, and so it says write out the first 5 terms. Well, that means find the first term by plugging in 1 for n. So in the numerator, it's 2 to the 1. In the denominator, it's 1 factorial. That's 2 over 1, which is 2. The first term's 2. I'm going to repeat that 4 more times. So next I'll plug in 2. 2 to the 2 over 2 factorial. 2 squared is 4. 2 factorial is 2, so the second term is 2. Third term would be 2 to the 3 over 3 factorial. Fourth term would be 2 to the 4th over 4 factorial. And fifth term would be 2 to the 5th over 5 factorial. So 2 cubed is 8. 3 factorial is 6, so that would be 4 thirds. 2 to the 4th is 16. 4 factorial is 24. So reduced, they're both divisible by 8. 2 thirds. And then 2 to the 5th is 32. That would be 120. So reduced. Four 15ths. All right, another place that we will see factorials is just in reducing expressions. So here we have 8 factorial over 2 factorial, 6 factorial. And instead of typing in what 8 factorial is and getting an answer, getting the bottom answer and reducing, we'll try to keep things as simple as we can by writing out the numbers for 8 factorial. Writing out the numbers for 2 factorial, and writing out the numbers for 6 factorial. It's supposed to be a 5. So what we can do there is, instead of actually multiplying those out and getting a large number, we can start reducing. Like there's a 6 on top and a 6 on the bottom. 5s, 4s, 3s, 2s, 1s. You never need a 1. So it actually ends up just being 56 on top and 2 on the bottom. So 56 divided by 2 is 28. Here we'll do the same thing. So 2 factorials, 2 times 1, 6 factorials, 6, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. 5 factorial, 5, 4, 3, 2, 1. We'll cancel out as much as we can. And we get 6 divided by 3, which is 2. For the last one, I don't have specific numbers, but I have n's. So I'm going to take the n, multiply it by 1 less than that, 2 less than that, until I get to 1. The bottom starts with n minus 1 factorial, so that's my first number. I have to multiply by 1 less than that, which would be n minus 2, 1 less than that, all the way until 1. So you can see we have some that are the same on the top and the bottom that I can cancel out. Everything in the middle would be the same, and then the ones are the same. So here we just end up with an n left.